actually revise with ourselves what are the procedures that we need to take in developing research papers for machine learning experiments. So there are standards that need to be followed. Of course, there are always rooms for innovations and bringing things that are really very new to it. However, there are some very important aspects that we need to all remember and never miss them. That missing them actually can be a source of challenge for us. So, and the unique thing is it is general, it is generic. You can always apply it to any area of application of machine learning that we are targeting. And the Microsoft Word document of this format will be shared in our forum, that is in the Telegram and the WhatsApp group. So you can have it and you are free to reuse it as you might want. Of course, like I said, there's always room for innovation, change this there, bring more things that were not there, but there are some standards that can never be kind of missed. Now, of course, starting from the beginning, we had of course, the title is very important, the author and the affiliations. Now, the most important I usually used to mention is the abstract and the introduction. Your abstract is very, very important because even people who don't have access to your paper, let's say your paper is not open access, people need to pay before they can access your paper. Those are subscription-based journals. They will have access to your abstract for free. So it is when they have seen your abstract and they found it noteworthy or they found it worthy of purchase, they will go ahead and purchase your paper irrespective of the amount. So it's like the abstract is the gateway to your work. So if the abstract is well written, that is good, excellent. Otherwise, even a paper with very excellent work inside might actually not call the attention of others because of poorly written abstract. So this is where we are going to start today. We say, okay, what do we put in the abstract? So we summarize it. I personally summarized it in the 3 whys, 3 questions that you must answer. The first question is you must answer the what. You must answer the what. That is, I call it what, why, and how. And then the summary of result and the implication of results. Those are 4 parts that must be present in an abstract. No matter how small the abstract is. Some journals or conferences will ask you to present your abstract in like 100, 120 words. Some more than that, but not really much. So no matter how small your abstract is, you need to make it to be very kind of comprehensive. That is, it must cover those things that are very important. So the what is where you describe exactly what you want to, the problem you want to solve. What are you trying to deal with? Very simple, but clear. And remember, we do our citation. You cannot make reference to any citation in abstract. Then the next is why. Then why are you doing this work? So in the why, you have to answer the question from 2 points of view. I divided it into 2. That is, what the first why is the topic necessary to be investigated? They tell us the importance of the topic, the challenges, that not solving the problem, this is the challenge that is going to create, or this is the problem people are facing, and that's why we have to solve this problem. Now, so once you have answered the question why it is important, we all know how to do this. That is, tell us why that particular topic is very important to you or to the community, and what the people tend to gain from it. And the next part of why is you need to tell us why from the point of view of earlier work done and the gap identified. See, what is the earlier work that has been done in this area? So because the fact that a particular work is important, is good, it's going to create opportunity. However, someone already did it before. Why do we need to reinvent the wheel? If there's a solution to that problem, why do we need to do it again? This is why this why from the point of literature survey is very important. You have to go to literature and check. Okay, has anyone done this work? Yeah, they did it already. However, there is a problem with the method used. I think I have a better method to use to solve this problem. It could be that the accuracy is not enough. A medical prediction that is having 80%, even 91, 92%, you still need to work on it to push it towards 100%. So you must have a justification, which is called the gap that you want to fill. So we must tell the reader what is the gap that you are trying to fill with this research or this particular project you are trying to do. Tell us something that is making your work to be unique. And it's good to take it in order as it is. What you want to do, why you are doing it, why from 2 points of view, the importance, and also from literature survey. You don't need to number it 1, 2, 3. It doesn't number. You can just write them in a statement after statement, and everything must be in one paragraph. And the next thing is to tell us, once you have answered the question why, convincingly from 2 points of view, from the importance and also the literature gap identified, then you move to how. How do you want to solve this problem? So the how you want to solve the problem also is divided into 2. That is, tell us how you want to solve the problem, like telling us the method or the algorithm. We want to use machine learning for this problem. Okay, which type of machine learning? We're going to use maybe k-nearest neighbor, support vector machine. Then the next is why of how. Then why do you want to use support vector machine? Why not decision tree? So you need to also tell the reader why you are choosing that particular solution, because there could be several others. So tell us a little bit of why it is important. So that is under how. So what, why, how, and then finally, then give us the summary of the result outcome and implication of the result. Okay, tell us what is, if it is a proposal you are writing, then you tell us what is the expected result. But usually when you are writing a final report, it is assumed that you already completed the research, then you need to tell us the results, summary, and the implication. You can tell us, okay, technique A performed better than technique B by so percentage of accuracy, and this is the implication in this particular area of application. Once that is done, then the abstract is completely written. However, notice that I said there's no room for citation. However, when you write this kind of thing, sometimes you want to make reference to, there's an opportunity for you to do that when we are talking of the introduction. You see, actually introduction, a popular question for research students is, what is the difference between abstract and introduction? Actually, introduction is an extended abstract. That is, what we've discussed in the abstract need to be repeated in introduction, but in a more detailed format. Because in introduction, you are encouraged, unlike abstract, you are encouraged to include as many citations as possible when you are writing introduction. So, because citation will make people to know that, yeah, you are aware of what you are dealing with. That is, you are well read in that area. You are aware of the literature. So the same 3 questions has to be answered. What you want to do. Here you say what you want to do in the very clear manner, while telling us citation, make citation to it. According to the World Health Organization, so millions of people are suffering from diabetes. Give us fact that we can reference what you are trying to deal with so that it can be very clear to people. Then the next is to go to why you want to do it. Tell us why the topic is important. You can cite references also to support why it is important. According to so government data, so number of people are suffering from this particular disease. There's need for us to tackle this. The more citation in introduction, the better. It's never too much, by the way. The more citation, the better in introduction, because it shows that you are well aware of that area. And the viewers oftentimes like that idea, because if you write your introduction that everything is from your head, I mean, it's like your own wedding throughout. No citation, no reference to any source. Actually, some reviewers do lose interest in reading further. because they look at it, okay, is he a renowned person in this area? Why is he not having any reference to any literature that's already published to justify, to support some of the statements being made? We are not saying you cannot make your own statement. No, it's encouraged to. If I what the references, you have to write them in your own words. However, you read the source and you try to cite what they have stated, not necessarily quoting them. Yeah. So you answer the question why, just like you did in abstract. The difference is that in introduction, try to support with references as much as possible. Why from telling on the advantages or the importance, and why from the gap identified. So you need to cite some of the gaps that are identified. Okay, it must be noted that several works has been done in this area in the past. However, no one ever used these, and these. So you try to let people know, because once, if you are writing introduction and you just started describing what you want to do, you are describing the importance, but you didn't tell us why they need to do this work. Are you you are assuming that, or you are making us to believe that you are the first person to do this work. No one ever worked with it. Even if that is the case, you need to make it very clear in your abstract and introduction that it must be noted that this is the first time this thing is being done. Otherwise, reviewer will assume that something is missing. Where is the gap? No one ever worked in this area before in the literature, or you are not just aware of the literature. And that could actually disqualify the research. Because if someone has done something, you just decided to keep quiet, people will not keep quiet with you, because in the day of your defense or when you submitted, they will search. The first thing a reviewer will do is he will search your paper title to see if there's anything that is related to it. So if you are hiding it, someone will definitely find out. So that is why it's very, very important. We need to tell the gap from literature, and it's by far one of the most important aspects of your writing, because if it has been done before, then there's no need for you to do it. If you have to do it, then you must give justification how you want to make it different from what has been done before in the past. Now, so once you answer the question why you are doing it, then the next is also to tell us how you want to do it. Before I move to that, under the why of gap identification, it is very important to mention it here that sometimes we might need to merge, because you need to cite literature. Several work has been done in this area. For example, in this, cite as many as possible. If you have a separate literature survey section, then you can make it a little summary. Like in these days, they did this, in this, they did this. You don't need to go too detailed because you have another section for literature survey. However, in some papers, you want to combine your literature survey into your introduction. It's allowed, especially if the number of papers you have gotten to review, there are very few. Then there's no need to create a separate section for like 5, 6, 7 papers only. Just include it as part of your introduction. So while you are answering the question of the gap, why it is necessary from literature point of view, tell us that effort has been made in the past. For example, in Ismail et al. 2022, he has used social method to solve this problem. However, he didn't do this, or he achieved lesser accuracy. So as you try to review the paper in a very smart way, you tell us the weakness of the paper. And finally, you are going to summarize. You hand that little literature survey you are inserting into your introduction with a kind of a strong reason or a link to justify the need for your work, because that is very, very important. If we cannot link the literature, the available literature, to what we are doing now, the need for it, then there's no need for that particular work. Either because someone already did it, then you have to look for another work to do, or we get a way to create a gap. And I want to tell us this: in machine learning, there are usually several opportunities to create gaps in research that has been done. If you don't know how to create a gap, how to find out the gap that you can fill. Try to reach out to experienced experts so that they can guide you on how to identify the gaps. The gaps could be, maybe you need to introduce feature selection, you need to introduce another method, you need to bring in even totally new algorithms like developing ensemble and host of other means of creating gap. If there are not very clearly available gaps, depending on the problem and how important the problem is. So after the next is to go to how you want to solve the problem. In doing this, you need to tell us the method you want to use to solve the problem. Maybe tell us the algorithm that's going to be used. Maybe tell us the algorithm that is going to be used. Then it's not just enough. I said, tell us how you want to solve the problem by telling us the method and why of the how. Why are you using that method? Tell us we want to use SVM because it has been reported to solve medical problem with very high accuracy. We are using decision tree because it is very easier to explain decision tree to people who are not computer science oriented or to the client, and so many other justifications that you can bring up. Of course, based on citation, if you have better, the more citation, like I said, the better. Once you have done this, I believe you have written your introduction better. The final thing is to tell us what is the result that you have achieved. See, what are the results? Summarize your results. You can compare in terms of percentage, what is the improvement that A provided over techniques B? What is the percentage of accuracy you are providing against earlier work? Especially if someone work on the same data set you are working on, then it becomes compulsory for you to compare your work with their work. However, if you are using a totally new data set, then you need to use at least two methods, two techniques, so that you can compare the result of the two techniques to be able to tell us which one is better and why do you think this is better. So introduction gave you that privilege to talk more. As far as I know, there's no limit to the number of pages of your introduction. Of course, that doesn't mean you should make the full paper to be an introduction. But what I'm saying is that there is no limit to the number of pages you can write in your introduction. So especially if you want to add literature survey to introduction, but if your paper is going to be more, you are going to like review 15 papers, then there's no need to include just a little bit of little reference to several efforts has been made in the past, these days. However, these are the gaps identified. Then you create a separate section for the literature survey because you have several number of papers to be reviewed. However, when the number of papers is really very few, or the editor imposed number of pages you must write, in that case, just include your literature survey in your introduction. This is excellent and highly acceptable. And once we describe the results, tell us the implication of your results. What can we make out of it? Then after that, you can try to have what we call the remaining part of this work is organized as follows. Starting from section 2, try to tell us how you organize the remaining part of the work. Usually, some of the published work, they don't have table of content. So this usually serves as table of content for reviewers. However, it's not compulsory, but it's necessary, and I encourage it. When someone review your paper, it goes to the introduction to date. Okay, what are the other sections? Okay, they can see how you have arranged your work. So, and again, I mentioned that there should be as much citation as possible in the introduction to show your grasp of the field and the earlier research. So, and also sometimes we can bring it literature survey to join with introduction in a very smart way when you are answering the question, why? Why is it necessary to do this work? From literature point of view, just bring your literature survey to that section, and then you start writing then how you want to solve the problem. And it's very, very good to make it in that order. What do you want to do? Why are you doing it? And how you want to do it. In that case, it's very easy for someone to read and quickly assimilate and understand what you're trying to do and the justification, and then how you want to do it. And then finally, you summarize your result. The section 2, which is the literature survey, I think I've discussed this. It is optional. You can have a separate section for literature survey, especially if you have huge number of several number of papers you want to review. However, the number of papers to be reviewed are very few. There's no need to do that. Just merge it with introduction in a smart way. See, you don't need to write so much about it that people will get lost in the review. No, the very small thing on the review so that they can still connect your introduction, because what is very important is the flow. We want it to flow. Someone has just read what you want to do. The next thing he has read the advantage, the importance, then he's reading the justification from literature. You don't want that literature to be too long to get him lost, because the next thing is how are you going to solve the problem, and the why of how, why are you using that method to solve the problem? And so you want it to still flow while you are having a little detail about the literature. So that's why I said you can smartly combine literature survey with introduction, but you have to be very smart in doing that. If you know you're going to be confused, then better to create a separate section so that in the gap analysis of the introduction, you just mention this paper, they have worked in this area. However, there's these gaps. Then that is enough. So, and then so in the literature survey, if you make it separate, it's also good also to summarize your literature survey in a tabular form so that people can easily grasp it, especially if you have space. Despite the fact you have reviewed each of these papers, you can also try to summarize them in a table to make it easier for people to go through and they can see the gap identifier. In fact, sometimes you can make a very smart table where each paper, you can tell us the gap that you identify in each paper, the gap. Although maybe out of like 15 paper, you identify like 12, more than 15 gaps. You cannot fill all the gaps in your work, but that's an opportunity for other researchers to consult your paper, and it becomes a kind of inspiration for them to know what to do next. Yeah. And the literature survey, we said it is very, very important that we pay more attention to previous work that use the same data set as the one you are using, because machine learning is all about data set. You see, if someone has used the same data set like you, then compulsorily you have to review that paper. It has to be a reference and the latest one. Sometimes the same data set have been used by maybe 15 people, each of them improving it, but do you still need something to be improved? Yes, then you go ahead and do it. The same data, it means those papers, they are the priority for you to review. They have used your data. But there are situations whereby you are the first one to use that data. Then in that case, you have the privilege of being free to know what are the data what are the papers that are relevant to your work. So you are not being confined to a particular paper. But for those that use your data set, then compulsorily you have to mention them. Compulsorily you have to compare your result with their results. This is how machine learning research works. And then the third section is what we call the description of the proposed techniques. We said at least 2 machine learning techniques must be chosen. This is a kind of pattern, so you have to describe it. We've talked about this in our earlier videos. We can refer to them. What you can do about it. How do you describe your techniques from mathematical point of view? So then we have the empirical studies also, like to point out, so that we all get it clearly. So the procedure we need to take. Empirical study, this is really where the actual machine learning experiment starts. It's starting with the description of your data set. Tell us more about your data set that we can know what you are doing, how many samples you have, how many features, where did you get the data from? Very, very important. So that people can reproduce. Always put in your mind that your reviewer is going to reproduce your paper. So if your data is missing, the link to your data is missing, how do you want him or her to reproduce your paper? This is number one place where a lot of people fail their review process, because the reviewer will just declare that the paper cannot be reproduced because a lot of things are missing. Although the reviewers might not have time to come and reproduce, but they want to see all the information that are needed to reproduce it in case someone wants to do that. So after describing your data set, you go to statistical analysis, tell us the mean, the median, standard deviation, maximum, minimum. Some people talk about the skewness of the data, left skew, right skew, and also of other statistical analysis you can include. Because seeing this one alone will give some information. Do we need to do normalization for this data or otherwise? So then also it's good to have correlation between the attribute and the target. Get them ready so that it's an indication of how are the inputs possibly going to affect the output. And we can also use the correlation between each attribute as a means to do feature selection later on in the experiment. Then the next is the experimental setup that we mentioned that we need to also pay attention to this. Tell us everything that you assumed or that you have used in your experiment. That if you don't tell us, there's no way we can know it. These are the questions you have to answer here. What is the partition ratio you are using? You are using direct partition, which we call holdout, 80% for training, 20% for testing, or 70% for training, 15% for testing, 15% for validation, or you are using n-fold cross-validation. Tell us all this, because if you don't tell us, there's no way someone will know what you have done, and that stands to disqualify your work through the reviewers. So tell us again, what are the method? Which environment did you run an experiment? Very important. This experiment has been run in Weka. It has been run in Python. Tell us those basic things. But don't tell us how to use Python. Don't tell us how to use Weka. That is not the business at this point. Anybody want to run Weka, we go online and see how to run Weka. So those questions that people can get answered to without you, you don't need to bother yourself about them. But those information questions that no one can know the answer except you, that you are carrying out the experiment, then those questions must be answered under experimental setup. To me, this is how, because students don't ask, how do we know what is enough in experimental setup and what is not enough? And I said, anything that if you don't tell us, there's no way we can know them, then you must tell us here. But anything we can know by ourselves, don't bother to tell us here. And another smart thing to do, if we can draw a kind of a very nice flow chart to show the flow of how you carry out the experiment, because it's very easier for people to follow a pictorial representation, especially when you use flow chart from data gathering, data pre-processing, model building. Tell us the procedure you have taken before you finally arrive at the final result. It could be this one. It could be the one that this is like a generic one. Majority of people will pass through, but sometimes you might have a kind of specialized one. Data collection, hyperparameter optimization, machine learning simulation, predicted results, performance is satisfactory. No, you go back again and do hyperparameter optimization until you are satisfied. So you can design your own flow chart to suit the way and manner you have done your experiment. It adds to the clarity of your experimental setup. Of course, the performance measure also, we need to mention what you are going to use to judge the performance of your experiment. Tell us there. So you are going to use root mean square error if you are doing regression, or you are going to use accuracy, ROC if you are dealing with a classification problem. A point I would like to mention here is, if you are using the same data set that someone used before, since you are going to compare your work with their work, then you must use the performance measure they use in their own experiment. Otherwise, your comparison will not be valid. You cannot compare an apple to an orange. See, if they have used root mean square error, you must use root mean square error. So whatever they have used, you need to also reproduce it, because their work is the kind of it's like a kind of maybe an experiment. Now you are going to compare your experiment with. So some things must be unique across board. But sometimes some of them miss very important performance measure. You can add it to your own as an additional performance measure, but you must include all their own performance measure It means your own must be richer than their own, or can be richer than their own, but must not be less than the earlier work. Let me put that way. Your performance measure cannot be less than what they have used. You can add more to your own, but you cannot have less than what they have used. Otherwise, your experiment will not be valid because you will not be able to compare your work with their work. And it's compulsory for you to do that if they have used the same data set you are using. Of course, the optimization strategy also, we've described this also in the earlier part before. So whereby you need to select what are the optimal parameters that are better. You have to search for it. We have different parameter search. We have videos that have described how to search parameter alone in Weka. So you can check up our channel for all those kind of optimization strategy. So you can make plug to make it very clear. And for people that have seen their work, majority of people are not having any mistake in this sense. So since people are getting it right. Yeah, another very important place I need to quickly mention before the time runs out is our result and discussion. Result and discussion is very, very important. Okay. See, the first thing is try to present the result, the initial result, as it is, without doing anything. Like I said, let the data speak. Don't spend too much time doing so much manipulation of your data. Don't manipulate data too much. You want to do normalization before you even normalize, except if you don't normalize, the system cannot even work on your data. See? Because you don't even do the normalization that work for you. So try to use the raw data as it is, do the experiment. If it works, that's fine. Even when you have imbalanced data, don't start treating imbalanced data right away. Try to run the experiment using the original data that is not balanced. Let us see the result of imbalance in the data. It's part of the experiment, by the way. And so your result from that raw data will tell us why you need to do other methods. Maybe you need to do normalization. Maybe you need to do balancing of the data. So the initial result should be put in a table. You see, of course, a little description of the discussion is very important. Any table you mention in your report must be discussed. Any figure mentioned must be discussed. These are very, very important. So you have to refer to them in the table above, table 1.0, describe what you put there, what is there, and then the implication of what you have seen. It could be seen from the result that the result is still very low. So next, we're going to have to maybe do feature selection, or we need to do normalization, or we need to do even balancing of the data. So initial result is very, very important. Then if we decide to go for investigating the effect of feature selection, which is optional, we can look at the part 4 of that, of our last, part 4 of the anxiety prediction paper. We discussed it extensively there, how to do this feature selection. So if you need to do feature selection, I say it's optional, because if your work is fine, with the initial work, everything looks good, then there's no need to go for feature selection. However, sometimes you want to do it as part of the present or future work. Okay, if we are getting 99% accuracy now, and we are using like 27 features, can we reduce the number of features to maybe lesser? Because that's going to make us to spend less time to collect the data. It's cheaper to collect lesser information, and so many other advantages of using lesser feature selection. So if you are going to develop a system that will use 27 features and you're achieving 99% accuracy, and I want to develop it using only 5 features, getting the same accuracy, you can see the big difference actually. So this is the essence of feature selection. Sometimes it is optional. You might not want to do it in your first research. Maybe the next research you want to investigate that because you are okay with what you have. If you are doing that, we can refer back to our feature selection. We have described them. There are several feature selection types, but I do recommend the very simple one, which we call correlation-based feature selection, where you rank your features, and every time you divide the number of features by 2, so use the full feature. The next thing, use all the feature, use number of feature divided by 2. You have like 10 feature, 10 divided by 2, use 5 feature here, tell us the result. Use 3, because 5 divided by 2 is going to be 2.5. You round it up to 3. Use 3 features. Keep doing that until you are left with only 1 feature, and you use the 1 feature and tell us all the results. Another mistake people used to have is they only run the experiment they do this experiment, but they only report for the feature that gave them the best result. No, you have to tell us the result of each of the steps. When you use all the data, all the features, half of the feature, until you get to 1 feature. Tell us all the result. From the table, someone can see that, oh, this one is getting better. Then finally, you have to go to, of course, you are going to discuss whatever result you have here. You try to discuss it. You try to discuss what result you have gotten, which one is better in the feature selection procedure. Then final results. In most cases, I've seen it missing in people's report. See, this one is where you're going to pick the best. If you have done feature selection, pick the one that gave you the best result here. You are going to put it here. If you have not done feature selection, then the one that gave you the best result from the beginning. Since this is the one that gave the best result, then you just need to lift it here. It means the one with, when you use the best, maybe partition, if you check different partition you are using, the one that gave you the best optimization, optimized parameter values, then you need to put that particular result here, because this is your final result. Sorry, this is your final result. And now you not discuss it. See, I said that from the experimental result you have had, you need to present the one with the best number of features used and the best parameter identified to now develop the final model. So you pick the best feature you have identified. If we are using all the features, that is fine. Use all the features and the best parameter identified and develop the final model. This final model, you can upload the necessary graphs and table like confusion matrix, ROC, and so many other courses. This is where you are going to do the major discussion about your result. This is where you are going to do the major discussion of the results. So we put, this is techniques 1, k-nearest neighbor, support vector machine, and host of others. Talk about the result. Why is this one better? What if analysis, and host of other things that we can see. Here I say that support your discussions, because this is the final discussion of your work. Support your discussion with appropriate figures to enhance clarity and easy understanding. Support your discussion with what if analysis where applicable. Sometimes you do some what if analysis. What if we have done this? What could have happened? It's part of discussion of results. State the implication of the results and the benefits accruable where applicable to what we have achieved. So we don't just repeat what is in the table as discussion of result. We can see in the table, you see that support vector machine is better than this. So that is not really discussion of results. You need to bring more life to that discussion of result. You might want to compare the result based on percentage. One has achieved 99, one is achieving 98. What is the difference between them? Instead of just telling us SVM got 99%, why this one got 98? We can see it in the table. No need to repeat that particular wording, but rather you can tell us, we can see that support vector machine outperformed the other method by 20%. So you see, so when we discuss, we want to bring information that is not available in the table to the system. That is the summary of discussion. So you can compare the percentage differences between each of the models. One is getting 99, another one is getting 97. Don't repeat the numbers, but rather tell us what is the percentage difference between the two, because that is informative. We cannot see it in the table, but you are putting it for us in your discussion. So these are things you will need to mention when we are discussing our result. And support with as many figures. You can put all the results side by side in a bar chart. You see one is up, another one is down. Those are pictorially, people can quickly see which one is better. And then further discussion, this one also is optional. This is optional. The previous discussion is compulsory, but this one is optional. If you have a data set that has been used before, this is what you are using, Then you create a further discussion to compare your work with the earlier work. This is what basically you do in the further discussion. You want to compare your work with earlier work. Here you are going to have a plot, another table that put your own result, the best of your result, side by side, the earlier results appropriately. Now, so you're going to put your results side by side with the earlier results to show the superiority of your work. And then you make some discussion, compare it, what if analysis. Why do you think you have gotten better result than the earlier people? What did you use that did not use? And then finally, you can also put, of course, appropriate pictorial representations and the likes, as the case may be. Now, and of course, finally, we have the conclusion and recommendation. Here you conclude your work and provide suggestions for possible future work, starting from restating the research problem addressed in the paper, summarize your overall argument or findings, suggest the key takeaways from your paper, and include possible future works in your conclusion and recommendation. So that people like to read your paper because they are going to see a lot of ideas. Because while you are working on your experiment, a lot of ideas will be coming to you, but you cannot always digress to them. Otherwise, you will never finish your research. So you have to streamline. You have fence in and fence out. Fence in are those things you are going to include in your work. Fence out are those, although they are related, but you can do it later. All those ideas that kept coming to your mind in the course of your work, you can write it as future work so that you can do it later. Other people can also benefit by laying their hand on your paper, and they can be able to get inspired to do some of this future work you have identified. So I think those are some of those things based on the feedbacks that we feel we need to repeat for ourselves when it comes to how to report our experimental results from machine learning point of view. And of course, we always encourage us to use the reference manager in case we don't use it. One of it is what we call a Mendeley, very, very light and free. So from my experience, it's very, 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 very light, and also it works very well. You can just get paper online, automatically added to the work. So this is what we are going to have regarding how to report experiment on machine learning for the day. So thank you for listening. So if we have any question, we can raise up our hand for identification before we call it. We move to the next segment, which is going to be some announcements for us, and then we're going to end the class. Thank you very much for listening. So we listen to your reaction or questions answered. Thank you.